Hello everyone. Today I'm going to take you through the workflow of creating a 3D model. This 3D model will be created using a G-code file. The G-code file is what the 3D printer accepts. There's several steps between taking this raw source data of LAZ files and converting them into what can be a G-code. So we're going to get started with it here. This is the coast.noaa.gov//hdata. That is where the LiDAR repository. You can find places all over the country. They've got great data sets there, and you can take any of those data sets, apply this workflow, and create a 3D model. So to begin, you need to identify the study area. For us, obviously, we're using this study area because our site is in Colleton in Beaufort County. So I'm not going to go in and do Beaufort County. It's repetitive, and you'll understand the workflow after this. But the Beaufort and Colleton LAS files will be merged inside of ArcGIS into one TIFF, but that'll come later. For now, you need to begin by downloading the tile index. Once this index is downloaded, you can save it to your hard drive and render it in ArcMap or QGIS or in any other GIS format that you're familiar with. It's going to download as a shapefile, so it's very easy to use. Once that tile index is rendered in whatever software you're using, you can then you set a shapefile as your project boundary and overlay it against the tile index. That is how you're going to identify the tiles that you're using. As you see here, these first 8 letters correspond to the date the flight was taken, December 27th, 2006. And these back numbers are the actual tiling scheme. So this is what you want to look at. The 490552 will help you to decide which tiles you need. Once they're downloaded, you're going to render them in ArcMap. Before you do that, we're going to go into LAS tools and extract these LAZ files into LAS. This is the LAS tools program. This program, we're going to use it to convert our LAZ data set into LAS files. The LAZ files will not be recognized by most GIS software, so we need to extract them into LAS files to be able to use them. My LAZ data set is stored. Oh, nope. Okay, so here are my LAZ files. And as I go down and add them, okay. So LAZ files are added up here. We've got filtered, no, transform, projection, overlays. Nice. Okay, now we need the output is going to go back into the index, which is going to be fine. There's some nice options there if you need to use any of those. I do not. Target projection, UTM zone 17 north. This is critical. Output format, LAS. Otherwise, we're just converting them back into LAZ, which in my case, ArcMap will not be able to render, and I will have made no progress. So now I'm going to run 32, start, and then we'll have our LAS data set after that. Now that we've successfully used LAS tools to convert our LAZ files to LAS files with the proper the proper coordinate scheme, we are going to load the LAS files into our ArcMap. So here's the LAS files. As you see, they look similar to the tiling scheme, except these actually have the LAS data inside of them. So when you zoom in, we'll see, there it is, starting to actually render the data. We don't need to do this right now though. So I'm going to back out to where we just see, there we go. Okay, now that we've got all the LAS files rendered and ready to go, we're going to create our LAS data set. To do this, go to your catalog and right-click on whichever folder you would like to create the LAS data set in. Once you right-click, you'll have the option for New. And after you go to new, scroll to LAS dataset. You can then name it whatever you would like. And once you've created the LAS dataset, you're going to right click on it again, or on it, click properties, and then under the files tab, you can add files, and you're going to want to add all of the LAS files to this LAS dataset. Once this is complete, we're going to run the LAS dataset to raster tool. LAS dataset to raster. And the input LAS dataset will be whatever you're using, which in my case is 3D Rice. The output raster can be whatever you want to call it. And then you've got some sampling value and Z factor options at the bottom that you can play with to get the correct accuracy and precision that you want on it. Okay, now that the file has been converted to a TIFF, we're going to add it, 3D raster.tiff, into our QGIS map. QGIS has these really great plugins, so we're going to search for DEM to 3D. This will export an STL file, which we can save on our external hard drive or thumb drive and plug directly into the 3D printer. So, well, that would be, we would use this. Okay, here we go. Raster DEM to 3D. Apologies. Okay, so to set the extent, we would like to go to the extent of 3D raster, which as you see, it did a fine job finding the edges there. Spacing, we're going to do 0.2. I'm going to choose 381 millimeters for this because I would like it to be the full size of 15 inches, and it's auto-filling to keep the ratio correct, but you need to make sure that you don't oversize it. So if I was to put 381 millimeters in the length, we would have a width of almost 3 times that, over 3 times that. So we are going to do 381, 15 inches, as large as it can be. And exaggeration factor, I'm going to enter a 10 times exaggeration factor because of there's hardly any topography here. So that'll help accentuate some of the vertical factors a little bit more. We're going to start at the base and export to STL, and then we'll be ready to print. So I hope you've enjoyed the video. Thank you for tuning in, and good luck with your 3D printing.